In this video, I want to talk to you about methods for quality improvement. And so let's just jump right into it. Over the years, there's been lots of different buzzwords. Quality control, SPC, statistical process control, TQM, total quality management, Six Sigma analysis. These terms come and go, but the ideas are fairly similar. Taking a look at what we've seen this semester in regards to data and variation and distributions, and trying to figure out what we should expect to see in whatever field we're working with, and using it to learn about what we're doing to improve our product. So total quality management can be thought of this way. First, we're going to decide or define what the customer wants. Second, we're going to design a product to meet those needs. Third, we're going to produce a product that meets or exceeds the product design. Now, an easy way of thinking about this, and this is an old school pen, think about that cap sitting there on the right of that pen. What's the purpose? What does a customer want from a pen cap? Well, I think if you think about it too long, you might not put a whole lot of thought into your pen caps, but it caps the pen. Great name, right? Pen cap. It caps the pen. We want a pen cap that's going to cover that point up, that's going to cover that ink up, so that if that pen makes its way to a pocket or on a piece of paper or sitting on your desk, if it comes in contact with anything, the ink stays in the pen and doesn't leak all over the place and ruin something. So we want to design a product to meet those needs. Now, if you think about it, where do those pen caps come from? How are they made? And years ago, these questions like that would be like, I have absolutely no idea. But now there's cable shows how it's made, and pen caps are made by machinery. And those pen caps are going to be made in hundreds or thousands or 10,000s or millions at a time. And so they're going to be made very quickly by a machine. And what we need is the diameter of that pen cap to match the diameter of the pen, so that when you slide that cap over that point, over that edge of the pen, and it's going to fit snugly. Not too snugly so you can't get it off, but not loosely so that it's going to fall off, but just right. And there's a certain, the word we would use is there's going to be a certain tolerance of pen cap diameters that are going to be acceptable. It's probably a very small number. If the pen cap is measured in millimeters, it's probably just a fraction of a millimeter. As long as the pen cap diameter is within a certain range or a certain tolerance, it's going to perform its job the way we want it to. And so we design a product to meet those needs. We come up with the machinery and the engineering so that we can do that, and then we're going to produce that product that hopefully will do a good job. Now, most of us don't think a whole lot about our pen caps, and I'm sitting here as I'm talking, just sliding my pen cap on and off very easily, but very firmly. Most of us don't think about our pen caps because it does a job. It does a good job, and we don't have any problems with them because the product is meeting our needs. It's exceeding the product design. And so that's kind of what we want to do. Now, in our field, statistics, we can help in defining what the customer wants through data collection and sampling. We can get together a focus group and we can talk about pen caps. Probably won't be a real long conversation, to be honest with you, but whatever it is we're doing, we can talk to the customers and see what they want. Currently, I am producing some wood products. I started a little wood business on the side, and what's the customer want? I'm making some artistic cutting boards, if there is such a thing. I know that may sound weird to you, but I'm making some artistic cutting boards. And the folks that are buying my cutting boards are talking to me about buying the cutting boards. I'm asking them, what do they want? I'm getting feedback. I'm selecting some data. I'm sampling to try to get some feedback so I can custom tailor what I provide to what it is they may actually want to buy down the road. Designing a product to meet those needs, that's an engineering question usually, but producing the product. The main emphasis of total quality management is to attempt to quantify whether a product is meeting or exceeding the product design. So we're going to produce some product and then try to decide if it's working or not. So let's jump into it here a little bit. First, quality. What the heck is that? How do you define quality? Well, most people think, well, it's good. It's a good product. Well, it's indicated by the extent to which a product satisfies the needs of its user. How happy are you with it? And so I remember years ago, I was at this meeting with the county, and we were trying to talk about the quality of our life. How do you define the quality of your life? In fact, I'm currently working on a study with Hillsborough County right now. Hillsborough County, Florida, that is. Trying to see how people in Hillsborough County what they feel about the quality of their life. How is it compared to this time last year? How about 10 years ago? How about 6 years ago? How about 4 years ago? And so we're trying to figure that out. And quality is kind of a tough little word. How do you, if someone were to ask you, how's the quality of your life? How do you even answer that question? Well, you begin by looking at different dimensions or facets of your life, or what does it mean to have quality? And this is one of the slides or that would be given in a textbook. 8 dimensions of quality. Performance, the primary operating characteristic of the product. For an for an automobile, this would include acceleration, handling, smoothness, ride, gas mileage, so forth. Depending on what year you're looking for a car, some of those attributes are more important than others. For instance, gas mileage is more important now than it was maybe 10 years ago when gas prices were lower. Depending what happens with gas prices in the next 5, 10, 15, 20 years, it's going to change again. If gas prices come way down, people don't care about gas mileage. If they go way out, we care a whole lot. So performance is the primary operating characteristics. The features are the bells and whistles. And this is a little old, as you'll see. The bells and whistles that supplement the product's basic functions. Examples include CD players. I mentioned this might be a little old. Digital clocks. Free drinks offered by airlines. Frequent flyer mileage. Think about your some restaurants you go to. Do you have one of their bonus or benefit cards or whatever they happen to call them? Frequent feeder cards is what I call them. The more you eat there, the more you get free stuff. Those are features. How about reliability? Reflects the probability that the products will operate properly within a given period of time. When you're spending a bunch of money on an automobile, you want it to last for a while. Conformance goes back to the pen caps I was talking about a little while ago. The extent or degree to which a product meets pre-established standards. Think about the pen caps, and they're talking about caps for plastic bottles. But what's the diameter? What's the tolerance? Durability, the life of the product. Serviceability, the ease of the repair, speed of repair, competence and courtesy of the repair staff. Depending what you're working with or what you're talking about, different pieces here become more important. I remember I used to have an automobile, I'll leave the dealership out of it. Their service department was terrible. Every time I'd go in to get service, just an oil change on my SUV at the time, it was like pulling teeth. I hated it. And then I remember a little after that, I got rid of that SUV and I got an Acura. I'll mention this one because I have positive things to say about it. I got an Acura for a little while. I had a sedan. And boy, when I went in there, the service department was great. They always did what they said they were going to do. It was always ready early. They washed it. They vacuumed it. It was a completely different experience. Now, I probably paid out the nose for the service at the Acura dealership. I probably paid a lot more money than the other dealership when I didn't have a good experience. But it left such a good taste in my mouth. It really gave me good feelings and thoughts and emotions about that dealership. I wouldn't hesitate to purchase an Acura in the future. That other dealership, they got to have a really good product because I don't think I would ever go back to that type of car again or that type of truck again. The aesthetics, how a product looks, feels, sounds, smells, or tastes. And then there's other things, such factors as a firm's reputation, image of the firm, its products that are created, other perceptions of quality. So quality is kind of a difficult little word to get a definition for because you can think about it a lot of different ways. How's the quality, and boy, this is a dangerous question, how's the quality of my teaching? You know, what are some things you'd think of? Are you learning? Are you entertained? Are you, do I encourage you to come to class? Does the experience, what would you say? And that's really what you do on your evaluations at the end of the semester. You're trying to report back to the university what you think about the classes you're taking. What's the quality of the learning experience? So just some things to think about. 8 dimensions of quality. I'm sure it's not limited to this. And some of these like reliability and durability and serviceability, there's overlap there. If it's reliable, it's probably durable. If it's durable, maybe it doesn't need to be serviced. So just some things to think about. All right, so let's go on to our next slide, and let's talk about a couple definitions. Let's think about the process, and we're going to define process a couple different ways. A series of actions or operations that change inputs to outputs. And what I think about here is I want to think about we're creating something. And a lot of this quality improvement material got its start in a manufacturing setting. And so we're making widgets. Oh gosh, that's a terrible example. I'll give you a better example in a second. But you start with some material, you do something to it, and it's better. And then you do something else, and it's improved. A process is a series of actions or operations that change inputs to outputs. Another way of thinking about it, a series of actions or operations that add value. So maybe you start, I don't even know what a widget is. Well, it's that fictitious product. But we start with some material, maybe we bend it. And now we have a bended piece of material that's better than just the piece of material. And then maybe we paint it. And then maybe we do this, and maybe we do that. And each time we do something, it's getting more and more usable. Okay, and as I'm thinking about this, I'm thinking about my cutting boards. I start with pieces of lumber, just 8-foot pieces of lumber. And then I cut them into maybe like 16-inch sections. And then I cut different patterns out so that they can fit together. And then I glue them together. And then I plane them smooth. And then I cut out a rectangle, and then I sand it, and then I put some finish on it. All of a sudden, the pieces of wood that I started with and the bottle of glue, all of a sudden I got myself a decent little cutting board that hopefully someone's going to want to pay some money for. And so each step along the way is considered a process. And what we're going to be doing is taking a look at those processes and see if there's anything we can be doing better. Can we improve each of those processes? The way that I cut the boards, am I doing it the most efficient, most consistent manner? The way that I create my pattern pieces, are they going to fit together real nicely, or is there going to be gaps in between? Because no one's going to want to buy a cutting board with gaps in it. So each of those steps along the way is called a process. The entire system is all those processes put together. Okay, you do this, and then you do that, and then you do this, and you do that, and those sticks of wood that I start with, that glue in the bottle, all of a sudden at the end, I have a cutting board I can sell. And so that's a mission that I have. I look out in my shop and I see that material, and I know what's going to happen at the end of the day. And so there's processes are put in place so that I can create, in my case, a cutting board or a table or whatever it is I'm building. And so a system is just a series of connected processes. All right, moving on. That's what it looks like. You start with an input, and then you do process 1, process 2, process 3, and sometimes there's a whole lot of processes, and you end up with an output. And I just kind of talked you through the cutting board example, and that was pretty quick and dirty, but let me give you another example. Back in my college days, this is going back maybe 1 or 2 decades. I worked at a company. I lived up in Pennsylvania, and I worked in a company called Richardson Vicks. I have no idea if that company still exists, or if it's still the same ownership, or if it's even still in the same building. But Richardson Vicks made a lot of pharmaceutical products, things like Clearasil, shampoo. I worked on the Vidal Sassoon shampoo line for a little bit. And what I spent most of my summer doing one summer was making Vicks 44 cough syrup. And Vicks 44 cough syrup, I think, is still around. Yeah, I think it looks something like that. That's kind of what it looked like when we made it, those many years ago. They came in glass bottles. I think they were like 8 ounces or 12 ounces. I can't read on that what it says. But they were glass bottles, and they were filled with cough syrup. And we had a production facility. Now you might be asking, what's the horseshoe over here? Well, the horseshoe is kind of the shape of the production facility. There was a big aisle out here, and forklift trucks would go back and forth in this aisle. And you didn't want to walk out in this aisle, because if you walked out in that aisle, there's always a chance of getting run over by a fork truck, which was not a good thing. So we stayed pretty much in our little section here. And the space, just to kind of give you an idea, if you're in a big lecture room, like the room that I pretty much teach in most of the time, about the size of that room was the production area. So if you think about this, maybe, I don't know, maybe 30 feet this way and 40 or 50 feet this way. So maybe about 1,200 square feet, 1,000 square feet is where my production line was at. And what would happen is bottles would be delivered on a pallet. So that fork truck would come, and right about here, she would drop off. There was a fork truck lift lady. She would drop off a pallet, and on that pallet were boxes. And so they'd just be stacked. And they were kind of, I would get a pallet of boxes. That's the pallet I'm drawing right now. And they would be dropped off right here. Now I stood right here. This is X marks my spot. Because my job, I was bottle boy. I was the bottle tipper. My job was to take a razor knife. These boxes were probably, I don't know, maybe 2 feet long by 16 inches wide, and maybe, I'm looking at my hands here, maybe another 16 inches high. So decent sized boxes. Inside those boxes were the bottles. My job was to cut open the top, fold back the edges, and there was a piece of cardboard on top. I would flip the box, upside down, and then I would take that little piece of cardboard out. I would lift up, and there'd be another piece of cardboard about midway, and that other piece of cardboard separated two levels of bottles in the box. I would grab that piece of cardboard and lift up, and those bottles would be started on the production line. And then once they kind of moved along, there was like a turntable. Sometimes you go to grocery stores and you put your items on a conveyor belt. Other grocery stores, maybe old school grocery stores, had one that kind of turned. That's what I had. I had a big turntable, and I put the bottles on the turntable. When I lifted them up, the turntable would just kind of pull them away from me, and then I could put the second level down, take the other piece of cardboard out, freeing the second level of bottles. And that's what I did. And then I would break the box down and put it on the floor over here. So you have a used box over here. Then I'd grab another box and do it again, and I'd do the same process. And eventually I would have a stack of empty boxes here, and my pallet would start to decrease. It would start to get smaller. When I got down the bottom, the fork truck lady would just put the boxes on the pallet. She'd take them away, and she'd bring me a new pallet of bottles. And we'd do it all over again. And that's what started the process. I started the process. That was my job. I would free the bottle. I was a bottle liberator. I got them out of their bondage. They were in the boxes, and I set them free. And then off they would go. And then they would go down this direction. So I started them here, and they would start their little turn, and off they would go. And about here, there was a machine that slapped a label, like the one you see here pictured in the bottle. And it would slap a label on the front. It would slap a label on the back. Then it would go, and there was another machine here that quickly put cough syrup into the bottles. Because when I got them, they were empty bottles. I added value. My process, I freed the bottles. Then they got value added in the second process where a label was put on. The labeled bottles are more important or more valuable than the empty bottle. And then they were filled with cough syrup. And then a cap was placed on the machine. Very high rate of speed. I remember the capper machine was always kind of a crazy one because these were done at a very high rate of speed. When the capper machine broke down, the caps would go flying. And if you think about this stuff happening at kind of warp speed really fast, when the capper machine would screw up, there was a lot of torque involved, a lot of twisting motions. These caps would fly. Now, most of the people that worked on this production line, there was some summer help like me, but most of them were long timers, like these 50, 60-year-old ladies. This is what they did. They watched these bottles all day long. Really boring job, but that's what they did. The capper lady had a dangerous job. She would have like a helmet and real thick clothing, because when the capper went bad, those caps flew at high rates of speed, and you just hear some old lady down the line screaming, "Ah!" And we'd all try to stop the production line. But the caps added value. They added value to the bottle. Now we have a bottle with cough syrup with a cap on it. Then they'd get a safety seal. There's a little plastic seal that kind of went over the bottle, over the cap, and so that people realized that, yeah, well, it's safe. No, there's nothing, nobody tampered with the cough syrup. Then they were put in individual boxes. Back in the day, we had these little boxes. Each bottle was put in a box. Then they had plastic wrap, another layer of protection, and eventually they were put in cartons. And so as they're working away, maybe the bottle tipper, I started here, then the labeler was here, then the fill machine, and then maybe the capper was down here, and safety seals were added here, and then they were put in their boxes, and then they had plastic wraps, and by the time it worked its way, and all the time it's just kind of going around this horseshoe type production facility. Then there was a bunch of guys that worked here, and they took a bunch of these wrapped, boxed, sealed, capped cough syrup bottles, and they put them in cartons. And so they had a pallet over here that they would put box after box. I guess cartons is probably how I should be saying this. And they would create a stack. And so the stack of bottles I started with over here, as it reduced, this one over here got big. And so the same lady that brought me the bottles, she would take these, drop off the bottles to me, and then she'd come here and take those to shipping. And that was our system, made up of 9 loosely defined processes. Now, our job in the quality improvement is to kind of think about each of these processes, and we try to measure them. Okay, so when I look at, see if I can draw without, there you go, the link went away. When I look at this label here, well, one thing we can measure, a qualitative variable we can measure is, does it have the label, yes or no? Another one can be, what's the angle? Is it perfectly straight, or did it get put on, is it cockeyed? Is it kind of like this on the bottle, which just looks sloppy? Is the cap, how tight, the torqueness, or the torque, I guess is the right word. How tight is grandma going to be able to open the bottle? Is your 2-year-old son going to be able to open the bottle? Because in one case we want grandma, in the second case we really don't want your 2-year-old son to get in there without you saying, "Yay, let's have some cough syrup." So how tight? How much strength does it take to remove that cap? The fill machine. How much cough syrup is in here? Is it filled all the way up? And this is the example I use with the fill machine. There's not the same amount of cough syrup in each bottle. Now, to check this theory out, to see if you believe me or not, next time you're at the grocery store, go to the 2-liter soda aisle. Look at all those Cokes and Pepsis and Mountain Dews and whatever sodas. They're just lined up. They're like the aisle of soda soldiers just waiting to be taken home. They're just standing at attention waiting for you to grab them. But take a look at them from a different perspective rather than trying to see what brand you like or what you're going to buy. Take a look at how much soda is in the bottles. Usually they're clear plastic bottles. Sometimes they're like a green bottle, but most of the times they're clear and you can see how much soda is in a bottle. Take a look at the space in what I'll call the neck of the bottle. Look from one bottle to the next, and probably what you're going to notice is they're not exactly the same. They're not all filled with the same amount of soda because, well, what we've learned this semester is variation happens. And we want to learn about that variation. Now, you probably haven't ever noticed that before because the variation that you see in the bottles is so small relative to the size of the bottles. It's not like one's going to be all the way filled and the other one's half filled. They're all pretty much full, but there is slight variation from one bottle to the next. And it's that variation that we want to keep control of. The soda companies don't care that there's variation as long as we don't care. But once we start looking at bottles and saying, hey, wait a second, that one doesn't have as much soda as the other one, then that becomes a problem. Because now I'm going to pick through the bottles that are there, and I'm going to choose the full bottles and leave the empty ones behind. And then I'm going to get frustrated with my soda manufacturer and say, well, man, I'm just tired of dealing with this. I'm going to switch to a different soda, or I'm going to switch to a different drink altogether. And so variation, we can measure that. And at each process, whoops, lost my shipping, there we go. At each process, we want to try to take a look at something that we can measure. Now, maybe once an hour at my production line, there would be folks that come and they had a little cart. They had this little cart on wheels, and we called them the lab coats because they worked up in the office and they had lab coats on. And they would come in and they would kind of check their watches. They'd stand about here, and then they would just start going to the line, and they would come over here and come over here and come over here and come over here, and they'd pull bottles off, and they'd put them in their little cart, and then they would take off. And at the time, I had no idea what they were doing, but they were measuring things. They were the quality improvement people. They were measuring different attributes of these bottles that they were taking off the line to look for variation, to see where variation was occurring, to see if it was variation that we should naturally expect, because as we know, variation happens. You're not going to get exactly the same amount of cough syrup in the bottles every single time. Or was it variation that was due to other factors? And so that's where we want to move to next. Let's talk about the sources of variation. And I guess my output here, I didn't have that up there for you. The Vicks 44 cough syrup was ready to ship. All right, let's talk about sources of variation. There are 6 that are listed that are your primary sources of variation. People mess up. People cause variations. I don't do the same things or the same way, or I cause variation in the systems that I set up. Another example that I use sometimes with this system and processes, think about how you get up in the morning. Most of us, and especially maybe not now when you're in college, but as you get older, most of us have a system that's in play in the morning. Now, the system may change from year to year, or decade to decade, or season of life to season of life, but most of us have a season because most of us have the same goal. It doesn't matter who we are, what our background is, but most of us have the same goal. We want to maximize how much sleep we get. Let's face it, we don't. Once you're asleep, you want to stay asleep. Sleep is a good thing. Some of you guys are probably nodding your head thinking, yeah, I know exactly what you're talking about. Now, it's kind of funny to me because in the morning we want to maximize our sleep. We want to try to stay in bed as long as we can till we have to get up and get moving to someplace, work, school, whatever it happens to be for us. So we want to try to maximize the amount of sleep in the morning. Now, what I always find humorous with this, especially when I have this discussion with college students, is most of us don't try to do that from the other side. You're like, what is he talking about? Most of us don't try to maximize the sleep by the time we go to bed. Most of us, when we're awake, we're like, hey, let's try to stay up as late as we can. And so we don't think about maximizing the sleep from what time I go to bed, but we all try to maximize our sleep from what time I get up in the morning. If I can squeeze 2 more minutes out of the day, I'm going to do it. Now, the season of life I'm in right now, I don't teach real early classes. In the spring or in the fall semester, the earliest class I teach is 11 a.m. This is crazy, but in the spring semester, the earliest class I teach is 3:30 in the afternoon. And so maximizing sleep shouldn't seem like a big deal to me, but the current season I'm in, my wife gets up at like 6:30 every morning, and I get up with her. I make her coffee. We have a small time together in the morning. So I'm getting up early, and we're trying to try to squeeze every single minute we can out of that. Well, to do that, we have a system, and you probably do too. How do you get up in the morning? Do you do it the same way, or do you kind of just haphazardly get up and just kind of make your way? And if you get dressed, you get dressed. If a shower happens, so be it. Eating is optional. Probably not. There's probably a system. You do this, and then you do that, and then you do this, and then you do that. Now, a lot of times there's other people involved, and people cause variations. I know when my kids were young, they caused variations. They didn't always get up the way that I wanted them to. They didn't always move as fast. So people cause variations. Machines. You know, if you want a bagel in the morning and your toaster's not working, or your toaster oven's not working, or this isn't happening, or machines play a role. If my hot water heater is broken, that's going to cause a problem. That's going to cause some variation in my morning. Usually it speeds things up for me, because if my hot water's not working, my shower doesn't last as long as it would if it was. So sometimes the variation can work for you, sometimes it works against you, but machines play a role. The materials that you use. I was making some cutting boards the other day, and the wood that I purchased, I didn't notice it when I purchased the wood, had a lot of knots in it. And knot is just kind of a circular area in the wood that's not real good for cutting boards. And so there was a lot of waste in the material, and it ended up costing a lot more money because I couldn't use a lot of the material. So the materials that you use. The method, sometimes the way that you're doing what you're doing isn't the most efficient. And the methods themselves can cause variation. The way we measure, sometimes our measurement techniques don't measure. Like if you're trying to measure the diameter of a pen cap with a ruler, boy, you're going to get some variation just because you can't measure that accurately. And then lastly, the environment. And I'll tell you a little story about the environment. The place where I did the Richardson Vicks, the Vicks 44 cough syrup, it was really faint, and you could barely notice. This is I told you our area was maybe like 1,000 square feet, but the production facility we're in was probably tens of thousands of square feet because there was a bunch of production lines. It wasn't just ours, and then there's all that material that's being stored. It was this huge warehouse, and in that environment, it's loud. There's a lot of machinery, but if you listened real closely, there's a term I haven't heard it used very much recently, but it's a term for music called muzak. It's like M-U-Z-A-K, and it was a term that was used where you took what was once a popular song and you took all the vocals out, and it was music, but it was kind of dumbed down music. Sometimes it's referred to as elevator music. Occasionally you're in an elevator and you'll hear music, soft music playing in the background, and it's like, gosh, I think I know that tune, but it's dumbed down to such a level that no one really likes it anymore. That's called muzak. That's what I'll call muzak. And when I was working at this production facility, every 15 minutes they would turn this kind of crappy music on in the background. And it would play for 15 minutes, and then they turn it off. Then they turn it on for 15 more minutes, and then they turn it off. And then they turn it on for 15 more minutes. And then that was the environment. And I mean, there's this hum of machinery, and there's people yelling, but in the background there's this light kind of terrible music playing. And then not playing, and then playing. And the folks that we worked with or worked for had determined that was the environment that created the least amount of variation. That kept us, without even hearing it really, without even thinking about it, that kept us on task, productive, doing the best we could do. And so each of those things can change. People can cause variation, machines, materials, methods, measurement, environment. And each of those sources along the way, if you're adding variation, that's a bad thing. Your product's getting a little bit crazy. Your amount of soda in the bottles is getting more varied. There's highs and there's lows, and all of a sudden customers are going to care. And so we're trying to keep track of the variation and to see when we have too much. Trying to understand when the variation is just due to the natural tendency of things or when it's due to some other factors. And these are some factors that can cause variation. So how do we do this? Well, use our knowledge of the process, what we do, to identify when it's operating outside its expected. Ooh, we've talked a lot about expected range of performance. We've talked about expected in the context of a z-distribution. We know what to expect when we're working with a z-distribution. Well, we know what to expect when the process is working like it should. And so we're going to use something called control charts. And a control chart is really just a time series plot. It's a scatter plot, except we're going to take a look at data collected over time. One of the problems I've seen before is where they're working with cereal boxes. And a cereal box has 24 ounces of cereal, and in this particular example, 20 days worth of cereal boxes. So they sampled 5 cereal boxes. The sample size is used in this quality improvement stuff is real small typically. But let's say we went to 20 different days and we sampled 5 boxes, and we looked at the sample mean, and the sample mean of the first day, it was like 24.05 ounces, and then there was 24 or 23.99 ounces, and you can see the different sample means. Now the averages, or the weight that's listed on the box, is 24 ounces, and so somewhere in here, like about here, I guess, that's where we should, if I kind of draw a dotted line going across here, that's where we should see the weights. Oops, went a little low there. They should be 24 ounces, and again, these are samples, X bar, for 5 different cereal boxes sampled on these days. But you can see there's a lot of days where we're less than that. That's a bad thing. So the control charts are just going to plot the data collected over time. Now, that's a scatter plot, and you can see some things in that, but a control chart is going to do a couple things. First, we're going to give it another name. We're going to call it a runs chart, or a run chart, and that's what it looks like. Now, it's exactly the same data that we were looking at on the last slide. So let me flip back there. Okay, you can kind of see here, if I do this, if I say, okay, we're going to go here, 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 and oops, so it goes up higher. Sorry, I missed that. And then it comes down, and it goes up. If I connect the points, that's what you're going to see. It's exact same data. And it does add, you see I went in and added the line. Well, it puts one in. It's called the center line. Adds what are called control limits. That's what this thing's called. That's called an upper control limit. This is going to be called a lower control limit. Now, if you were to look at the formulas, how you get these limits, they're not using standard deviations. They use some other math. Now, a lot of this stuff was developed, oh gosh, 50, 60, 70 years ago. And calculations like standard deviations, it's tough for you guys to really understand this, but calculations like standard deviations were really challenging 50, 60, 70 years ago. And you're thinking, why would that be a big challenge? We just figured it out on the computer. Yeah, we do. We didn't do that 50, 60, 70 years ago. And you're like, well, just use a calculator. I said, yeah, you can. We couldn't do that 50, 60, 70 years ago. And some of you guys probably are like, really? Yeah, when this stuff got its start, calculators hadn't been invented. Calculators are a relatively new invention. And you're probably thinking, that's crazy. Ask your parents. Ask your parents if they remember their first calculator. I bet they do. Or I bet they know somebody who got a calculator and like, wow, what's that? I remember life prior to calculators. So I bet your parents do as well. Anyway, the calculations are based on other formulas. But I don't care about those formulas. We're not even going to look at those formulas. I want you to think about 3 standard deviation limits. Earlier this semester, we learned that most things fall within 3 standard deviations of the mean. That's how I want you to think about these control limits. We shouldn't see any observations outside of those 3 standard deviation limits, those control limits. And then obviously in this picture, we connected the points as well. This is called a control chart. It's really the same idea as a scatter plot, it's a very simple graph, very easy to generate. Now, statistical control is where we want to go next. I think this is a good time for me to stop this video, and I'll pick up with that the next time we get together. So we'll talk about what it means for a process. Let's end with this slide. What does it mean for this process to be in control? Is this variation due to things that are normal? And I'm not talking about normally distributed, but are expected, or is this variation unexpected? How do we begin to think about that? And that's the discussion called control, statistical control. So that's where we'll pick up next time. So hopefully stuff we talked about here made a little sense. Now it's a little bit different than things we've been looking at recently in class. Not so technical, not so task oriented like our test hypothesis is you did this, you did that, you did that, you did that. This is more touchy-feely. Hopefully you'll find it a little bit simpler too. So we'll pick up with our discussion of statistical control. So long.